Have you ever thought that if I tell you to run an AI application completely offline, then how do you do that? No, it's not thought in my mind, it's a real world business problem on the ground. I hear leaders talking day in and day out that they want AI application to run completely offline, data not going anywhere, any API call should not be made, and nothing should be online. How do you solve this problem? This is called local first AI stack problem, and I am going to show you an hybrid approach where you will have this local first AI stack which can also use cloud if needed. Please ensure you watch this video till end guys, not because I am going to show you a very fancy project, but I am going to give you lot of talking points when you talk to decision makers. So we are going to understand the local first AI stack, and before we go into any detail, let's try to understand what the problem is, because once we understand problem then we will know why local first AI stack is in discussion. Now many a times you will see that whenever you are using an API to use AI, so for example when you are using OpenAI API to do some work in your generative AI project, right, what you will see is data or prompt is mostly leaving the premises of the company. So for example, if you are sending a query with some data, that data leaves the premises and it hits the server, it hits the API, it goes somewhere and then brings back the response. So this is one way in which AI projects are built. Now the problem here is there is data protection which is in question. So every time your data leaves your premises, right, then data protection is one thing that remains in the gray zone. Okay, then suppose if I want to run this entire application offline, so for working like this, right, your application needs to be online, you need to be connected to internet. Suppose for some reason I want to run the application offline, then what happens? Can I use the API way? No, I cannot use the API way. So if there is a situation where I need to run a model in, let's say, an environment where internet availability is not there, then that online mode will not work. And third thing is, suppose I can face some unforeseen situations with the API. So when you are using OpenAI API, right, so when you are hitting the server, you can get rate limit error, or maybe I have not seen that, but we can sometimes get no response, we can sometimes get issue with the key, we can sometimes get some other things that can come with the online way of accessing the model. So due to these reasons that you see here, right, and most important of that is data protection, data security, or data sovereignty in the given environment. Due to these reasons, many companies which are in, for example, BFSI, or which are in, let's say, pharma kind of sector, or which are any kind of regulatory sector, any kind of sensitive data they are dealing with, many of these organizations are looking for local first AI stack. And what are the reasons for that? They want to run things in their own premises, they never want data to leave their premises, and they never want to compromise on, let's say, rate limit error or any kind of technical glitches. They don't want that. Now I'm not saying here only local, I am saying local first. What is the meaning of this? The meaning of this is, think like there is a switch and this switch can send the request to local or cloud based on complexity of the query. So this is not a complete local setup, this is a local first AI stack that I am talking about here. We will see the project now, but first part you need to understand what problem we are trying to solve and what hybrid mechanism we are trying to build and what are the reasons to build that, right? Now few things to keep in mind whenever you want to keep it local heavy. Few things you need to keep in mind, and first thing is your model needs to be small. Okay, so model size cannot be very huge. The reason for that is very simple. Whatever you do, when you are hosting everything in local, the infrastructure has some constraints, right? So your model size cannot be very huge. If you want to use a larger model, right, then also you can use quantization or you can use compression techniques so that your model size get reduced and you can use in your machine. Now some of you who do not know what quantization is, go to YouTube and search for unfold data science quantization, and you will find a detailed video on what is quantization, how it works with examples as well. So this is a method to make your model size small for using it in these kind of constraint environments, right? Your model size need to be small, just keep that in mind. The second thing you need to keep in mind is you need to have a local inference server. This is critical here, okay? Local inference server. The meaning of this is there has to be some application running or some service running that will listen to my requests. So imagine there is a uh, server running, web server running, and this web server will give the response to any of my requests. But this is a must. Without this, I cannot use a local first AI stack. Now, in our example, how we will enable this local inference server is we will use Ollama in the background, okay, and we will use one of the Ollama model. And what we will do is we will write the function in such a way that it is compatible with both Ollama and OpenAI, because as I told you, we will be building a hybrid kind of setup, right? So it can go to Ollama and it can go to OpenAI if needed, just by one line of switch, okay? Either it can go this way or that way, but remember you need to have a local inference server. Without this you cannot have a local first AI stack. The third thing in local first AI stack you need to remember is, if you are building an RAG application or any kind of application where you are doing some embeddings, storing that knowledge, comparing, right, you need to have a air gapped RAG pipeline. So what is the meaning of air gapped RAG pipeline? Just an example I am giving you, air gapped RAG pipeline. The meaning of this is, can I run my RAG locally? And when I say running RAG locally means, most of you know that for running RAG you will need a database, right? And in this database you want to store some knowledge, right? The only thing to take care here is this database should sit in the local environment, right? So what I said here, your LLM or your server or your listener should sit in the local environment. Similarly, your database or your knowledge need to sit in the local environment. The key thing here is no data should leave the machine, be it knowledge or be it your prompt. No data should leave the local machine or local infra or local premises or local setup, whatever you call it, okay? And then the fourth component that you can have in a local first AI stack is hybrid router, that I already explained you above. What is hybrid router? Hybrid router is nothing but a mechanism which will route your query in direction A or direction B depending on the complexity of the query, okay? And then you can also have some benchmarking mechanism. So benchmarking mechanism means when I'm doing a local thing, then how is my different metric which I want to capture. For example, you can capture something like token per second, you can capture the speed in different ways, you can capture the response time, and so on and so forth. And these things you can capture when the request is going to local, when the request is going to cloud, okay? So you can have a benchmarking. And what I'm going to do is I'm going to show you a complete demo which will consist of 3 or 4 different parts, okay? Demo 1, demo 2, demo 3, demo 4, demo 5, like that. So what will demo 1 do is, demo 1 will build a RAG in local. So I'll not use any cloud service or anything which is outside of my local machine. If you are interested in seeing the cloud part, again go to YouTube and search Unfold Data Science RAG. You will find a lot of useful videos where I have explained how RAG works and basically the cloud RAG. But here I will show you the local RAG. In demo 2 I will show you how the hybrid router works. Okay, based on the complexity of the requests, how the hybrid router works. In demo 3 I will show you how the inference is running. So basically raw http call to server. So server will be running in my local machine, and if I make a http call, that server will be called. That is your raw http call to server. Then I will show you how the OpenAI Python client is working for local inference server as well. So OpenAI Python client for localhost. Okay, localhost or local server you can think of. And then in the end we will simply see comparison. Comparison means what is good in local, what is good in remote, and so on, right? So first we will see the GitHub code, and then we will see the demo. So if you come to the GitHub, you will see that I have a project here called local first, and in this project what happens is we are running a local OpenAI compatible inference server. We are building an air-gapped RAG pipeline with ChromaDB. Benchmark token per second we are doing, the benchmarking that I told you. We are implementing intelligent hybrid routing, that is local versus cloud. And in the architecture we are doing application layer, then the hybrid router, then the local LLM, then the cloud LLM, and then RAG pipeline. So it's simple. There is a router and it can go to local or cloud based on complexity. Here I have written Ollama pull Mistral. What you can do is you can simply do this, or in Ollama UI also you can download the model like this. Okay, so Ollama will be running in the background, and then I am running this file called servlocalmodel.py. Now what is there in this file? Let's see. Servlocalmodel.py does nothing. It simply calls that local model using some request. For example, if you see here, there is a function called send to Ollama chat. There is a function called send to Ollama completion. So it will use the Ollama internal model and it will create, if you see here, right, these function signatures are just like OpenAI function signatures, and this, and the reason we have kept it like this is I want to flip it if I have to move to cloud. That's it. So if Ollama is running in background, it will simply start a local server where our requests can be served, okay, using fast API. So this is your serve local. So what I will do is I will go here, and in this project, right, I will start my local server. Let me start my local server, Python serve local model.py. So if I run this, right, it's the same project. You will see that UVCon running on HTTP this. So my local server has started. Okay, and now what I will do is I can show you all the demo one by one, or I can show it together using Python example uses.py. So if I go here, right, and if I show you Python example uses.py, you will see that first of all I am trying to show you the demo of the RAG, and in this RAG local text storage opening from ChromaDB, document is getting ingested, RAG agent is getting called, and then there are two queries which is getting asked. So this is the RAG part. Now where is the RAG code? RAG code is here in RAG pipeline. So if you see here, right, Chroma collection name, embedding model name, Chroma directory, and local server port, all these things come from config. So if you see here, right, Chroma collection name, embedding model name, complexity threshold, and preferred local is true by default, so that is coming. Local server host I have given, local server port I have given, Ollama host address I have given, and Ollama model, which model I want to use, I have given, right. And if you want to use cloud, then you can give OpenAI key, OpenAI base, and which cloud model you want to use. So basically all these things are here in configuration. Now if I go to example uses again, you will see that whatever was there in RAG pipeline, here there will be ingest document, here there will be retrieve, and here there will be RAG agent. So this RAG agent, these are the knowledge. This knowledge gets ingested, these sample documents get ingested, and then we ask the query. Okay, so this you can run alone, or you can run in example uses.py as well. Now if I go to example.py part 2, you will see there is a hybrid router logic. And if I go to hybrid router, right, you will see that there are some simple tasks and complex tasks defined, and we will analyze the complexity, and then hybrid router will route whether it is a cloud related task basically based on the complexity, or it is a local task. Okay, so call cloud, call local, and it will simply route it. But for now what we have done is we have simply said that force to local or preferred local is equal to true. So everything will run in local only. If you make it false and you supply some complex arguments, it will go to cloud as well. So that is about demo router. Demo API is nothing but API running in local that I showed you already here. Here API or server is running in local. So if I go to my browser also through Swagger UI, I can basically see that running, right? And then demo 4 is all about OpenAI swap. So before and after, what happens? So if you see before, right, base URL is this and API key will be given. After, base URL will change to local and API key will be ignored, and then it will be called based on this. So OpenAI local, API key ignored, because we are trying local now, right? So OpenAI swap we are using local now, so this will work. And this is just basically some writings of what happens in local, what happens in cloud, and so on. And here all these things are getting called: demo RAG, demo router, demo API, demo OpenAI swap, and demo comparison. So what I'm going to do is I'm going to run this file directly. Okay, so if I go to Visual Studio and if I go to another terminal and I say Python example uses.py, what should happen is my 5 demos should run one after another. What is my first demo? My first demo is my RAG. What should happen in the RAG? If I go to RAG, my documents first of all should get loaded into ChromaDB, and then 2 things that I have asked here. Don't worry about this one. This is the in this definition, right? But we are running example usage, so we are asking 2 questions here, right? Where is that? What is ChromaDB and how does quantization work? So those knowledge will get inserted and those questions should get answered. So if you see here, local agent stack, RAG pipeline, loading model, document ingested into ChromaDB, this is step 1. And then those 2 things: what is ChromaDB, how does quantization work? What is ChromaDB, how does quantization work? This is your first demo, first RAG demo. What is our second demo router? So here we need to see how the routing is happening. Okay, and here the prompt is summarize quantization in 1 sentence. So if I come here, right, you will see that simple, medium, complex, there is routing happening. This is for this one. Okay, simple, medium, complex, these 3 things are simple texts. And then here summarize quantization in 1 second, backend local, latency this, and response is this. So this is basically showing you the router and how the router is working. You can check more about hybrid router here. So the funda remains same. It will check a threshold. Based on the threshold, it will send it to local or to remote. But for now, I'm forcing it to go to the local. Okay, that is your part 2. Part 3 is demo API and local API health we are checking, and we are asking a query and we are getting the response. So this is working fine. Demo 4, we are trying to show 1 line swap before and after. So if you can see, before in cloud, I will go to HTTP API OpenAI v1 and I will give my API key. After, this is local environment URL and API key is ignored. So here we are using local. So quantization is the process. We are asking a query and we are getting the response. So what is quantization in one sentence we are asking and we are getting the response. So for now all our requests are going to local only. Okay. And then what are the local and cloud differences? So local inference, no API key, privacy, offline 10 to 50 token per second. This can change based on what model you use, but it is limited by hardware and it is smaller models normally. Cloud is unlimited compute, better models, managed service, cost per request will be there, internet will be required and data will go to cloud. And hybrid, which is our stack, is based of both cost optimized and fallback support. Why? Because we are sending complex ones to the cloud and easy ones to the easy or medium ones to the local. So this kind of hybrid setup is nowadays in lot of demand, is I am seeing with businesses, where businesses think that some of the things should remain not necessarily on complexity, but based on various other business factors, they think that some of things should remain internal, so local for that, and for other things you can go hybrid. So that is why I thought of explaining you local first AI stack. Don't forget to give me like and comment guys if you're liking these kind of enterprise AI content, because all this I'm talking from my personal experience and I bring a project and then show it to you. Okay, so hybrid but local first. Why? These reasons. What components you will need in local first? These components you will need, and then you can build your local first AI stack. I'll see you in next video guys. Wherever you are, stay safe and take care.